All right, in this problem, we are given 3 cubes, two of which we know the size of. We have a 3 by 3 and a 5 by 5. They're all stacked together. And we're told that these, and then this third cube, which we don't know the size of. And we're told that these 3 corners are all collinear, which means that they all lie on a straight line together. And we're asked to use that information to find the size of the third cube. And what I'm going to do here is a bit of a trick I'm going to use on several of these problems. Is I'm just going to put them in a coordinate plane. So I got my x-axis down here and my y-axis down here. And I'm going to write an equation for that line that passes through these 2 corners right here. And these would be the points 0, 3, and 3, 1, 2, 3, 4, 5. 3, 5. So I know those 2 points, and then I'll write that equation and use that to find the third one. So first thing we need to do is find the slope of this line. Find slope. Okay. So our change in y from point A to B, we'll call this A, B, and we'll call this point C. Our change in y goes from 3 to 5, and remember, end minus start equals change. So 5 minus 3 equals 2. And then for our change in x, it's going to be from 0 to 3. So 3 minus 0 is 3. So change in y, or change in x, 2/3. And now we're going to use our point slope form to write the equation. All right, so that was y equals mx minus h plus k, and as a reminder, m is slope and hk is our point. So let's just go fill it in. Y equals, our slope is 2/3. X minus, we'll pick, I'm going to pick the easy point. So I could have just done points or slope intercept form because I have the intercept, because that would have been easier. 3. All right, so we're going to pick this point down here, 0, 3. And plus 0. So I'll distribute here, and that's 2/3 x minus hold on a second. Hey, I'm daydreaming. I completely filled this out wrong. Shoop, shoop. That's y equals 2/3 x minus 0. The x coordinate is 0. So I was doing something wrong there. Plus 3. So y equals 2/3 x plus 3 is our equation. And now all we have to do is just feed that equation, feed it the x coordinate for this point. And we do know the x coordinate because it's 3 plus 5. So this point is 8, 0 right here. So the x coordinate of this point is 8. So to find the y coordinate, so let's see. Find, I'll call find point C. Right. So we're just going to plug 8 into this equation. So y equals 2/3 times 8 plus 3. That's going to be 16/3 plus 3. Let's see. 3 is 9/3 plus an additional 16/3 is 25/3, which is 8 1/3. Let's just check. 1, 2, 3, 4, 5, 6, 7, 8, and a little bit more. That makes sense. Okay. So again, our overall process was to take our 3 boxes and put them in the coordinate plane. It's a bit of a trick. We're going to use that trick again for other things. And then, since we're told that these 3 points are collinear, then we can write an equation for the line that passes through the first 2, and then use that equation by inputting the x coordinate for point C to find out what the y coordinate is. It's just a matter of plugging it into the equation. To write that equation for the line that passes through A and B, we needed to know the slope of the slope from A to B. We got 2/3, and then we need to write the equation, and I chose to use point slope form, where we input the slope and a point. But of course, like in retrospect, since I knew the y-intercept, I probably just should have done slope-intercept form. That would have been easier. And then, of course, now as soon as we have our equation, we just plug in the x-coordinate to get the y-coordinate for point C, which tells us how tall the square is, and therefore what the overall dimensions of the third square are.